All right, so a lot going on today. Okay, so if you checked your assignment sheet, we've got learning today, tomorrow. On Wednesday, we have a big review, which means you're only going to get 20 minutes with me in that meet. So here's my advice on the review. And I know you're going to have Tuesday night homework. And normally what happens in a review, people come in here, they're here the whole 50 minutes, and they start working on it. And in that 50 minutes, they discover some things they have questions with. Because we only have 20 minutes, if you roll in here on Wednesday to the meet, and just then pull up your review sheet and start looking at it, by the time you realize you have a question, the meet's over. So you still could technically, perhaps, sneak in on the 5th period meet, if you didn't have one, like if you had an elective or something, because I have the other Algebra 2 class 5th. So you could potentially sneak in there and maybe get a couple questions answered, or hang around. But what I would do is maybe take a look at that review sheet ahead of time, like before, like maybe the night before, whatever, and just scan through it, and you'll most likely be like, okay, I got that. Ooh, what about this sucker? And there might be a couple on there. And then when you roll into the meet, again, I'll do the same thing. I'll say, if you don't have any questions, you're welcome to go, and that'll dwindle down to like 3 or 4 people that actually have questions and want to get those answered. So that's my advice for that. Again, it's not a perfect scenario, but you guys will have that test on Thursday, and then on Friday, I've already made a video out, posted it, and you'll just kind of start the next chapter Friday and head into the weekend. All right? But we got some big stuff to do today. Some of it you're going to know, some of it you're not, I'm guessing. And I'm actually, if I have time, I'm going to try to get a little bit ahead of what we're doing, because if I can get a little bit ahead, it'll make tomorrow a lot easier to swallow. So jump to, I think it's page 29 in your book. Not the textbook, but the book. Okay, so the beginning of this, I don't think many people are going to have issues with. Okay, so the beginning of this, we're going to be talking about sketching inequalities. So I'm going to kind of quickly go through here. On your test, when you are here, you will have these number lines put on there. If I accidentally make a question and it's and your answer is everything greater than 8, or all x values greater than 8, and you're like, you don't have an 8 on here. If I accidentally do that, just go out here and extend it to 8 and say, all right, all the numbers greater than maybe or equal to 8. Do that if you need to. That's not the case here, but do that if you need to, because it seems like every year I do something and that happens. So I'll apologize ahead of time, but I want to make sure you guys are good on these, because then I'm going to throw a couple curveballs at you and start talking about and, the word and the word or, and what it means when you combine inequalities, like when you have more than one and you're trying to get a result. And it's really important. The word and the word or change everything. Literally, your answer will not even be close. So on your test, if you're taking your test and you're thinking, oh, and, or, tomato, tomato, drapes, curtains, whatever, if you're ignoring that word, you're going to be losing points on every single problem, because it is a big deal. Okay, and maybe the whole problem. So right here, what is this saying to you?
X is greater than 3.
So one way to think about it is x is greater than 3, or since x stands for the values or the numbers, I want all the numbers bigger than 3. Do I want bigger than or equal to? So how do I show just bigger at 3? So I got an open circle at 3, which means it can't be equal to 3. 3 greater than 3 is not true. But all the numbers bigger than 3 would be out here to the right. And you don't have to do much, but just draw a line. You don't have to be really fancy on that. And if you have homework problems tonight, honestly, this is, and you don't have this sheet in front of you and you're having to create your own number lines, don't spend, literally, this is what I would write if I was creating my own number line. I would mark the number 3, put an open circle, shade to the right. I am not going to put little tick marks all day long. And you virtual people, if you are unable to print out your test, but you need a number line, really, just draw the number line, mark the critical points, put those on there. Don't spend a lot of time trying to give me nice and pretty number lines. You will run out of time. Are you with me? Okay, what about that? All the numbers smaller than or equal to, so how do I mention -2? What do I circle? Color it in, so I got a closed circle at -2, and I'm going to shade to the left. All right, what about number 4? 4 greater than x. What does that mean?
All the numbers greater than, no.
Careful.
That's not correct.
4 greater than x technically means 4 is greater than all these numbers. Well, that would mean when I mark 4 with an open circle, it's bigger than all the numbers. What could I do if that's bothering me? If the x is on the right and it's bothering me, what could you do? Flip it over, and if I flip the x and the 4, I've also got to change the direction of that inequality. So if it helps you to think that way, x, all the numbers less than 4, then do that. Open circle, definitely go. Right here, -1 is less than or equal to all these numbers. So what's that the same thing as saying? X is, and you can even read it that way, right? If you kind of read it backwards, x is greater than or equal to -1 if you're reading that from right to left. So I'm going to shade to the right. Are y'all with me? Okay, awesome. What about number 5?
X is greater than or equal to -2, but less than 1.
So we call this a combined inequality, combined, or some people call it a 3-part inequality, but I think your book calls it combined inequalities because you've combined 2 together. When you have a problem like this is inherently an and. And when you have an and statement means it has to be true for both of them, not just one of them. Like for instance, the number 10 is bigger than -2, isn't it? But I can't say, hey, 10 is bigger than -2 and smaller than 1. Now, it doesn't mean or that would be true. 10 is bigger than -2 or smaller than 1. On or, it would just have to be true for one of them. But a combined inequality is like an and statement, which means it has to be true for both. So, bigger than a -2, so I'm going to mark that -2 with the closed circle. Smaller than a 1, open circle, and it has to be true for both, so you would have to shade where?
In between.
Right in between them. And most of the time, and problems look like this. Occasionally, an and problem will be a null set. Think about this one. Right here. I want numbers that are smaller than -2 and bigger than 1. Now, here's what people do by mistake sometimes. They go, wait, smaller than -2. This would be wrong. They say smaller than -2, bigger than or equal to 1. But that's not and, that's or. This would be like, hey, write down the numbers that are either smaller than -1 or they're bigger than 1 or equal to 1. That would be true if it was an or, but all combined inequalities are really what? And problems. So you have to read them like there's an and in there. You all tracking with me? So what would this be then? Are there any numbers that are smaller than -2 and bigger than 1? Null set. So I'm going to leave this blank. Do not, I have every now and then I'll have somebody that will shade stuff in on their number line and then write null set. But on my test, I'm explicitly going to say, put only your answer, not your thinking and your work. Put only your answer on the number line. So on this one, I'm just going to leave the number line blank and I can circle it if I want or whatever. You can write null set if it makes you feel like, hey, you do know that I'm not just skipping this way. If it makes you feel better, but the graph of it is just nothing. And then right here, how do you graph all real numbers? And y'all know this is actually the real number symbol, but when we normally do it, y'all know we just normally put like an R with like a little double bar right here. That's all real numbers to us, because we don't really get great scripts out of most students. So most professors just do like a little double bar R, but that would just be everything, so just shade the whole number line. And what does a null set mean? Nothing, so leave it alone. And by the way, every now and then I see people make a null set like this. You know what that is? That's the Greek letter phi. In America, we tend to say phi, but the Greeks pronounced it phi. That's the uppercase, lowercase, and then sometimes, so don't do that. And then every now and then I get this. You know what that is? That's like a 0 in the old computer programming fonts back in the late 80s that zeros would show up with these little lines through them. It's not that. It's just basically a zero with a diagonal line that extends a little past it. So that's a null set, so it's shading that. All right. Now, have y'all ever heard of interval notation? Okay, if you haven't, no worries, but math tournaments love interval notation. AP Cal, it's kind of 50-50. But AP interval notation is just another way of writing inequalities. And in my opinion, it's a little better. So right here, this would be an example of a number line with these values. Tell me if I'm right. Right? Interval notation just says to do this. Hey, if I'm starting at 3, I'm just going to put a 3 down. If I'm including it, I'm going to put a bracket. If I'm not including it, I'm going to put a parentheses. And then I'm just going to put a comma. And I'm going to write the next number is going to be how far it went to the right. So what did it go to on the right? Kind of infinity, went forever. So I'm just going to write infinity. And then because infinity goes forever, I can't really ever get to the very last value. I keep going. By rule, I just put parentheses. So that's interval notation. Now let's check out this one. This graph, I would have a -2 marked. It would be shaded in, and I'd be heading left, right? So what would interval notation be here? Now here's a mistake a lot of people make. A lot of people look here and they go, oh, I'm going to start at -2. This is wrong, so don't copy this step. I'm going to start at -2 and I'm going to go to negative infinity. And their thinking's great except for one thing. I always think left to right. So really, what do I have to start with? Negative infinity. So I'm going to start with negative infinity by rule with the parentheses, and I'm going to go all the way to what? So comma -2, and because I include -2, I'm going to put a bracket, not a parentheses. And if you ever forget this, here's a really lame way to remember. On open circles, I have parentheses, right? And on closed circles, right? On closed circles, that's where the graph is equal, right? If it's equal, you make a bracket. Totally lame, I know, but if that helps you remember, if you don't already know that. If it's bubbled in, bracket. If it's open circle, parentheses. All right? All right, so let's check out a couple of these inequalities. Do y'all remember how to solve, not equations, but inequations or inequalities? Is there any difference between solving that guy and if there was an equal sign? In terms of your algebra rules. I can think of one.
So do you have to flip it?
What do you mean flip it?
Or flip the,
So if I
divide
or multiply by a
negative.
negative number, then I
Flip the sign.
change the direction of that. Okay? Now, does that mean if the problem has a negative in it right there that you are going to change the sign? No. It means if you, in the process of solving for x, if you have to multiply this by a negative. Now, I probably am on this one, unless I do it a different way, and I can show you the other way. If I have to get rid of that sign by me multiplying by a negative, or you multiplying by a negative, or dividing by a negative, then yes, I'm going to flip that direction. So here's you tell me what you would do to solve this thing. First step. Distribute 3 in. Totally great. 6 minus 12x plus 5 less than or equal to -13. Now don't come in here right now and go, oh, there's a negative with the x, I got to change the direction. Have you or I multiplied by a negative yet? No. Okay? And that's me putting it in there. If there was a -3 right there, would I be changing the sign? No. I'm just distributing. You didn't do that. The problem did that, right? There's a big difference. So, at this point, what would you do?
Combine like terms.
Okay, I could combine that and get 11. Could I maybe save a step by just subtracting the 5 and subtracting the 6 from both sides and just save from an extra step on my paper? So what does that give me?
-12x is less than or equal to -24.
-24? Now, what are you about to do right now?
Divide by negative.
So because you are dividing by a -12, and guys, this is probably the number one mistake on this test. When I divide by a negative 12, I get x on the left, I get 2 on the right, but what do I have to remember?
Change the direction.
Change the direction of the inequality. Now, do I have to divide by negative 12? Check it out. Could I add, sorry, that's a 12, negative 12x. Could I have added 12x to this side, added 24, or to both sides, add 24 to both sides, and I still didn't divide by a negative, right? Then divide by a positive 12. Now, I wouldn't do this, but did I have to change the inequality? Is that the same thing as this stuff? Yeah. So I'd probably do this route, but just remember, when you, to do the algebra, choose to divide or multiply by a negative, you've got to change the direction of the inequality. All right? What if it was an equal sign? What happens when you flip an equal? That's why we don't, the rule technically applies for equations too. But when you flip an equal sign, it doesn't do anything. So we never really learned that. But when you divide by a negative, you always change the direction of your sign. It just doesn't happen. All right? So far, so good? Oh, and by the way, if I finally got down, what did you end up with, greater than or equal to 2? What if my directions were solve and graph? Well, what does that represent? Was this my final answer? Or was it less than? It was greater than?
Yes, that's correct.
So what would that represent if my directions were solve and graph? That's the solve, that's the solution. So to graph it, that's a separate step where you would come in here and color it in and shade to the right. But if it just says solve on your test, stop here. If it says solve and graph, don't make the mistake of just graphing it. I have people do that from time to time because I want to see your solution as well as your graph. All right? So far, so good? All right. So, do a couple more of these and make sure you're okay. What about 13? What would you do first? And there's two different things that you could potentially do here. Oh, and by the way, what are you going to do with a combined inequality on the algebra? Anybody got a guess? What do you mean by both? Both sounds like two. Oh, you mean both the left and the right?
Yeah.
What about the middle? You do it there too? So it's absolutely good. So on the rules of algebra, normally there's just two sides, right? So if you add 2, you do it to both sides. But if there's 3 parts, if I add 2, I gotta do it to all 3 parts. And then if I divide by -4, I gotta do it to all 3 parts. And if you divide by a negative, what do you think happens?
Signs flip.
The signs flip, right? You change the direction of those. So somebody give me what they would do first here.
Multiply everything. No, this.
Okay, usually people do one of two things. Let me show you how you end up the same way either way. So I heard distribute first, so I'm going to distribute. Now, did you put a negative in there, or was it already there?
It's already there.
It's already there, so don't change the signs right now. It was already there. I get a -4x minus a 24. Sorry, dang it, what am I? I'm not changing anything, right? No change because the problem already had the negative in it. Next step. But notice I only distributed there because that part only had the -4 around it. Now what would you do? Add a 24, but I got to do it to all 3 parts. So if I add a 24 there,
12.
positive 12. If I add a 24 to the middle,
-4.
-4x. Dang it, why do I keep flipping this thing? If I add a 24 to the right side,
Positive 16.
positive 16. Sorry about those of you at home. Last step. Maybe last step. How do I get the x by itself?
You divide everything.
Divide everything. So if I divide the left, the middle, and the right by -4, you divide it by a negative, so what do you have to do?
Put the signs.
So I get -3 on the left, x in the middle, -4 on the right, and I'm going to switch that direction to that. I'm going to switch that direction to that. Now, I have a question for you. What does this combined inequality inherently mean? And are their values bigger than -3 and smaller than a -4? Let's think about that on the number line. Are their values bigger than this -3, both, and smaller than this? No. So what does this mean? Does not exist is fine. DNE is what it'd be easier to write. So either that or DNE. But guys, if you make the mistake of sketching this, do you know what you just sketched? Let me make sure I didn't make a mistake on that. 24, 24, negative 24, negative 4, negative 3. Yeah, okay. So that would be just a DNE. So do not write that. That's what I write if it's an OR problem, which we're about to get to OR problems. But you know that three-part inequalities, combined inequalities, are inherently what? And problems. So you have to think as if it was and. And says it would have to be true for both. That doesn't mean, nothing works there, leave it blank. All right, what about this thing? This is going to be a little trickier here. Distribute? So I'm going to distribute. Oh, by the way, is there another way I could have done this?
Multiply everything by negative 1/4.
Or divide by negative 4? Same thing, right? If I divide by negative 4, I get 3. But I have to change the inequality. That goes away and I get x plus 6. Change that and I get 2. Right? And then what?
Subtract 3.
Sorry.
Or 6. Sorry.
Divide by negative 4, I get 2. 3. X plus 6.
Subtract 6
Okay.
from that.
Subtract 6 from all three sides. Did that feel a little easier? It did to me, but you can do it either way. So you get the same thing. All right, right here. Well, you said multiply 3 by 3. I probably would do that here because dividing by 3 on the right and the left just gives me a mess, doesn't it? So if I'm getting into fractions too early and I don't want to mess with them, maybe just distribute. So here we go. Somebody tell me what they would do next. And I'm going to intentionally mess with you here, so somebody take a shot.
Add 8 to all 3 parts.
Add 8. So let me ask you a question. Is it important to get this x by itself, or is it important to get that one? So maybe add what?
6.
Okay, so let's just try that. If I add 6 to all 3 parts, I get 4 plus x, 3x, 2x minus 2, or negative 2 plus 2x. Now what would you do? And what problem are you seeing here?
You can't isolate an x.
I'm going to build on what you said. Right here, she said cancel the x's on the left and the right. That's what I want to do. I want to end up with just x's in the middle here because then I can think about the number line. But I've got x's on the left and the right. Problem is I don't have the same amount. If I try to get rid of that x, what would you do? Subtract x from all 3 sides? Well, great. I got rid of the x, but guess what happens? I still have one over here. And if I try to get rid of that one, well, I got 2x minus 1x is x. I got this looking pretty and that looking pretty, but that doesn't look pretty. So what happens if I can't get if I don't have the same number of x's on the left and the right, I can't get them into the middle and gone. So do y'all remember what to do? I think Tyree might have touched this. If you had Tyree. A combined inequality is essentially what kind? An and. So, could I say, if this means this and that, with the word and in there, then shouldn't this mean this and that? Let's try that. Now, I'm not going to do that every time. I don't need to do it here. I got all the x's in the middle. But if I can't get them to the middle, then try this. So let's try it. Negative 2 plus x less than 3x minus 6. Then 3x minus 6 less than or equal negative 8 plus 2x. And what's the word in the middle? And. And what does and mean? Anything you shade on your number line has to be what? True for both of them. Not one or the other, but both of them. If your parents say, hey, I need you to clean your room and empty the garbage, do you have a choice of one or the other? If they tell you, hey, clean your room or empty the garbage, then you're probably like, well, I could do one and just be right, so you pick the easiest one, whatever. Technically, at home, you could have done both and be like really impressive to your parents. But in math, or means one or the other, and means both have to be true. So I'm going to solve this now. So I'm going to subtract x from both sides to get a 2x. I'm going to add 6 to both sides to get a 4. And I'm going to divide by 2. And look, I've got my x part. Y'all tracking with me on this? And then over here, I'm going to subtract 2x from both sides, add 6, and now I have that. And I'm going to bring down the word and. Now, did y'all see me make any careless error? Double check. So what this says is what? All the values of x bigger than 2. So here's 2. And I'm going to be going heading to the right. And all the values of x smaller than negative 2. That would mean, or equal, that. Now, of these points, are any of these points true for both? And what's my answer? Are y'all seeing that? Don't shade this. Because if you shade this, what you are saying, if I put all this down, that would be a great answer if it was or. Yeah, these answers or these answers would be true, but not both. So the only answers that are true for both would be none of them. No, none of these shaded points are true for both of those. All right? Okay, let's just put it together and make it really obvious. And if you can get this next part, I just finished making the test out, and it's probably 20 to 25 points on our test. It's doing questions like you're going to see right here, 15 on down. So let's take a look at this. 15 says, and I want this inequality, and this inequality and that one. So here's my thinking. All the numbers bigger than 4. There's 4. I'm going to put an open circle just on the top of this, not on the number line. I'm going to save my answer for the number line. Would that be this first inequality?
Yes.
Okay, second inequality. All the numbers smaller than or equal to 1. That would be a closed circle heading the other way. Now, which points are true for both? I want to shade it. Are there any points that are true for this and this? No, null set.
So are most hand problems just going to be null set?
No. Most hand problems are going to look like this. We just run into a bunch. Because I don't want y'all to get cocky, so I want you to really be on your toes. Most of them end up looking like this. Now look at this. Same two inequalities, right? Actually, no, they're not. Oh, I meant them to be. Hey, on number 16, everybody at home and everybody in here, change that to a less than or equal to. Because I accidentally have the same thing twice here. I want this one right here. So now, on 16, change that to a less than or equal to, guys, if you're at home. Is that now the same thing as this? And then also change that and to an or. My bad about this. So make sure you have this written down with or and less than or equal to 1. Now, are the inequalities the same? So if you were setting this up, wouldn't it still kind of look like this? Right? So you do the same startup. Now, here's the question with or. With or, you're going to shade any point as long as it's in this group or that group. So what do you end up shading? If it's true in here, shade it. If it's true in here, shade it. Either one, shade it. So what do you end up shading? Somebody take a risk.
1 all the way down and 4 all the way up.
So all of it.
Yeah.
So for an or, just put it all together. And you got it. For an and, there's got to be an overlap. You're going to see another and problem in a second. Okay? Look at greater than 4, okay. Why do I keep doing so many like this? Oh, well, I'll do another one. This one right here, less than or equal to negative 3. There's a negative 3. Closed in, heading to the left. There's a 2. Open. Greater is heading to the right. But wait, there's an and. And means what? It has to be true for both. Are there any points that are both smaller than that and bigger than this? No. You follow me? All right, let's check this one out. Greater than 4. I'm going to sketch that. Open at 4 to the right. Greater than 1. Closed to the right. What's the word? And. Now what does and mean? Has to be true for both. So which numbers show up on that number line and on this number line? Is the number 1 true in both?
No.
Is 2 or 3?
No.
Is even 4 true in both? No. But what about 4.1?
Sure.
It's in both. 4.2, 4.3, 4.4, from there on out. So since it's not true on both here because that's open, I got to leave it open. But from there on out, it's true all the way. What would happen if they were both closed?
4 would be.
Then the 4 would be colored in. But do you see the difference between the and? The and takes what they both have. They don't both, they're not both shaded, but they are shaded everywhere to the right. Y'all with me on that? What would it be if it was or, just to talk about it? Or means what? What do we say to do here on an or? Just put them all down? So what does or mean? Bring them all down. So what do I end up with? Everything greater than or equal to 1. Do I put a hole in there? Like if it was an or, if it was, don't copy this down because I don't want your notes to look bad. Because we'll get to one in a second. If it was an or, my answer would end up looking like this. Okay? But why would this be wrong here? To bring that down. It works in 4, right? 4 is bigger than or equal to 1, and it only has to work in one or the other on an or. Right, but this is the answer to the and part right there. All right? Now let's look at a bunch of or questions, and hopefully I didn't do this again, but I may have copied the same thing. I sure did. I did it on, dang it, what's wrong? Okay, I did it on this one, so I'm going to change one of these to get what I want. I'm going to hold off on 20. I'm going to do 20 last. What about this one? Greater than 4 or less than or equal to 1. Greater than 4 would be that. Less than or equal to 1 would be like that. But what does or tell you? Bring it all down, right? As long as it's true on this one, great. It's true on those, great. It doesn't have to be true for both, right? So bring it all down. And I gotta be honest, or normally looks like this in your work tonight. And normally looks like in between 2 points shaded, or usually looks like this. But I'm going to stretch it beyond what we do in the book, just because it's math team and I want y'all to be better. What about this one? I said I'd hold off on 20. What about 21? Let's look at it. Less than or equal to -3. I'm just going to put a dot there and head left. Greater than 2. Open, head right. What does or tell me to do?
Going down.
Bring it all down. What would and have told me to do? No, say good, good. What about 22? 22 tells me bigger than 4, bigger than or equal to 1. What does or tell me to do? Bring all of it down. Do I bring it all down like this? Why not? 4 works in one of them, so included. So don't do that. Just show me this. All right, let me show you another one here. What if I had, what if I made this greater than 4 or x less than or equal to 4? What's greater than 4 mean? Open to the right. What's less than or equal to 4 mean? Close to the left. What does or tell me?
Bring it down.
All of it? Or all of it with an open circle? Is that right? Why not?
Because it can can be 4.
It can be 4 in one of these, right? So no dot. I mean, no open circle. Now let me throw you a curveball. What would this look like if it was an and? Careful. Oh no, if it was an and, what would it be? It'd be a null set. Because even 4 doesn't work in both, does it? None of these are the same as those, and even there. If they were both equal, then what would your answer be with an and? 4. Y'all see that? Because the only point that's true in both would be that. And let me show you one I may have not really shown you. Just I'll make one up here. You can just put it, call it number 22b. What if I gave you x bigger than -3 and x smaller than 1? So I'm just going to mark the number 1 and the number, the number -3 and the number 1 on there. Okay, now let's think about it. Bigger than -3 would be open to the right. Are you following me? Smaller than 1 will be open and then to the left. And this is what most ands end up looking like. What would the and be then? The stuff in between, right? And aren't most ands combined inequalities anyway? And if I think about everything in between, can you think of another way to say everything in between -3 and 1? -3
less than
x
less than 1.
less than 1. Look, combined inequality, it's an and. And I gotta be honest, writing your answer like this is much better than writing an answer with an and sign, with the word and. You can't get away from ors. Remember, ors can't be written like this because combined inequalities are always ands. But ands, if you can get it down to here, ands can be written like this if you actually have an answer. If it's a null set, then just write null set. All right, you're going to get the hang of all this. And here's what I'm going to do. This period ends in 12 minutes. So your homework is on this. But because tomorrow takes so long to explain, I want to get started on it. So when I show you and start talking tomorrow, you'll be at home. But when I start talking about this, you're going to be like, oh yeah, I already got that part. And then we can practice it a little bit more and you'll feel a little bit better. Because all we have is one more section. But unfortunately, it's a long section to get in. And so I'm going to get a little bit of head start. So you're not going to see any of this. But I want to just mention a couple of things. Okay, so I want to talk about what absolute value means. And most people don't know, when they come in this class, don't know the real definition of absolute value. Most people, and you're about to say it right now, what does absolute value mean to you?
The distance the number is from 0.
The distance that a number is from 0 on a number line. That's actually very accurate for what you know right now for Algebra 1. Technically, numbers don't have to just be on a number line, they can also be on a plane. So imaginary numbers, which you'll find out about this year, actually can be graphed in planes. So it's always the distance from the origin, which on a number line is 0, but it could be the distance to the origin as well. But a lot of people just go, oh, absolute value, just make it positive. And that's where they get messed up. Because you guys have learned, and you might want to do this on a scratch sheet of paper or whatever if you want to take these notes down, but it's going to be important. Absolute value of -7. What is it? 7. Sounds like you just made it positive, right? But if you think about it, it is the distance from the origin. That distance is a length of 7. So that's true, but here's where you run into trouble. What if I have the absolute value of like x minus 2? How far is that? That's where you start getting in trouble. Okay? But I need to understand what this means. Okay? So I'm going to start really basic with you, and that is this. Back to the -7. You know that if it's negative, it becomes positive. What if it's positive? Then what? You just leave it alone, right? So negative values in the radical, change the sign. Positive values in the radical, leave them alone. Well, it sounds like to me what you just said is, if I have an absolute value of a number, sometimes the absolute value is going to be left alone. So you basically just throw out the absolute value, keep the number. Throw away the absolute value, keep the number. But sometimes, when you're taking the absolute value of a number, you've got to negate that to make it positive, which is like change the sign, right? So sometimes with an absolute value, you're going to take the number on the inside and change the sign. Now, you're looking at that probably, or maybe, and you're going, wait a minute, why did you make it negative? I thought we were trying to make it positive. What I'm saying is, what if x was negative 10? What would you have done to the negative 10 to make it positive? Change the sign, which is making the negative, you're putting an extra negative on there. So I would go negative 10 and it would become positive. So the real definition of absolute value is it's this. Sometimes the absolute value, whatever you're taking, you leave it alone, sometimes you negate it. Sometimes it's positive, sometimes it's negative. That's how you change absolute value. Now the real question is, when do you leave it alone? You know the answer to this. When do you leave an absolute value alone? When it's positive, what's the it?
The number inside
The number inside? And what's the number inside? X? Good. So I'm going to leave it alone when the x is positive. And technically, if it's 0, couldn't I kind of include 0 in there because 0 is neither positive nor negative? Now, when are you going to change the sign?
It's negative.
When it's negative? So I'm going to change the sign when the x is negative. That's your definition of absolute value. Y'all seen that? Now, here's how it's going to show up in your work tomorrow. You should. You're going to be given one of 3 kinds of questions. Let's just start with this. What if I gave you the absolute value of x? How about this? Minus 1 is 10. Now you guys are pretty smart. You could probably eyeball this and see it, right? What numbers would be true here for x? 11. What else? Negative 9. All right? Now watch me use my definition to get this right. Sometimes the stuff in the absolute value, I just drop the absolute value and leave it alone. Sometimes I just leave it alone. Bring over the equals 10. But sometimes what do? I change the sign of what? Everything that's in there. So sometimes I'm going to negate the whole thing, bring that down. Sometimes it's this, or sometimes it's that. That's your definition. Now, can you solve that? What would you do here to solve?
Add 1 to both sides.
Add 1. There's your 11 you just mentioned. What would you do here? Distribute the negative. Then what? Subtract the 1. Then what? Divide by a negative. You don't have an inequality, so you don't have to switch the sign, but you can do that, right? Didn't we say our answers were 11 and negative 9? Now, if you're looking at this right now and you're going, dude, really? You want me to show all this work for this? Not really. I mean, yes, the answer is, but if it was just a random problem, not really. But here's what you're going to see. You're going to see stuff a little bit more involved. Like, I tell you, we'll stick with equal right now. Can you eyeball what your answer is here? Maybe, if you're really good and you're running through problems in your head, but there's 2. So what might be a better plan? You can divide by 2, which I'd always do. Anything on the outside, by the way, I don't know if you knew this, I can't multiply numbers on the outside in unless they're positive. And since sometimes they're negative, it's just a terrible habit to get into. So what I'm going to do, if it's on the outside of an absolute value, I'm going to think of that absolute value like a big brick wall. I can't get in. I'm blocked out. And the only way to get rid of that absolute value is to use my definition to get rid of it. Positive, negative. So I'm going to get rid of the 2 first. I'm going to divide both sides by 2. All good? Now, the second I get the absolute value, now I'm looking at this. What's my definition say? Sometimes the stuff is what? Positive. Bring down the equal 6. Sometimes the stuff on the inside gets negated. Now, you can write it like this with the negative on the outside, but couldn't you just kind of put that negative through? What do I get here? Negative 3x plus 1. That's me negating this whole thing. Drop down to equal 6. Now, your book does it differently than this, and it's not healthy. Your book skips the definition of absolute value, and they write this down. And it's a terrible idea, and they teach it wrongly. Most of the time, the book is really great. They teach this. Just bring it down, bring down the equal, 6, negative 6. It's a terrible idea. It skips the definition of absolute value. I want you to learn the definition of absolute value, and you're showing me that by writing this. And or. Or? Can you solve this now? Add a 1. Divide by 3. Would anybody have randomly guessed 7/3 is your answer? I wouldn't have. What about this? Subtract a 1. Divide by a negative 3. And by the way, if I divide by a negative 3, the temptation for lots of you guys is to write this. Do you know how, like, have you ever eaten a steak with your bare hands? I think it tastes better. I have before. Like when I lived with and I was single, I wasn't married yet, and I just cooked a big steak, and I'm like, I don't know why this feels more like, I don't know, like wilderness carnal or something. I was like, this is awesome. Just killing it. But that's bad etiquette, right? I mean, if we chew with our mouth closed. You know you could actually taste flavor better when you open your mouth? Some cultures do that. They smack their lips, whatever, to show the person they really like their food. Here in America, we're like, mouth closed. You know, good etiquette. Math etiquette, we don't leave negatives on the bottom. They can go out to the side or on the top. So do this or leave it on the top, but don't do that. I'm not going to count wrong initially, maybe never, but it's like just crappy etiquette. Are y'all with me with this definition of inequality? And remember, these are ors. Now, these definitions of absolute value. Tomorrow, I'm going to remind you of this definition, and we're going to jump to inequalities and see how that works, and we're going to be able to get through it much more quickly, but none of this should be on your homework tonight. All right? Yeah, and if you got a who am I paper, you guys are fourth period. Throw it in the fourth period then. But let me talk about that for a second. Normally I would take it up, but I just started thinking about it. Your test is Thursday in here. And I won't see you again to be able to give you your homework back. So what I'm going to do is say, if you want to hold on to your homework, if you're somebody that goes, dude, I never look at homework when I study, then you can go ahead and turn it in if you want. But if you're like, whoa, I like studying with my homework, then hold on to it and just give everything to me on test day. But you can give me your who am I paper. Did my who am I paper say to wear a mask in the picture?
Yeah.
Good. In my other class, I said that for some reason. It's just so terrible. Did it? No. I want to be able to see your face.
We need to staple it.
But your who am I paper, you don't have to if you don't want, as long as you keep them together. But you can't. The stapler, y'all know how to use this stapler? You just slide it in there and it just all the way. Let it hit. Just put it in.
Oh.
Did you get an extra textbook here?
Did I not give it to you? Is this it? I think this is it. I'm not 100% sure. I thought I wrote your name. This has got to be it. It's not, just do your absolute best to get that one back to me. Hey, y'all have a good one.